The Hubble Space Telescope has been operating for over 30 years now, producing some of the best images of our universe we've ever seen. But since its launch in 2022, NASA's new flagship space telescope has been stealing a bit of its limelight. But why did Hubble get replaced? Why is JWST such a step forwards? Well, aside from the fact that JWST is a lot newer, with far more advanced detectors and a much larger mirror, the main reason that Hubble was replaced is because it can only see in the visible and the ultraviolet parts of the electromagnetic spectrum. And if you want to study our universe, that is a bit of a problem because of one major issue in astronomy: dust extinction. If you watched my recent tier list video, you will know that I rated dust extinction right at the bottom in F tier, and with good reason. The problem I had in that video was I didn't have enough time to go into quite why it is such a pain in the neck and why it deserved that F tier rating. So that's what this video is going to be about. In essence, dust extinction is the scattering and absorption of light as it passes through space. It interacts with dust grains in molecular clouds that may someday collapse down under their own gravity to form stars. Scattering and absorption are two processes with a common dependence: wavelength. The shorter your wavelength is, the more affected your light is going to be by dust grains in interstellar space. This same process of scattering light is the same process that gives us blue skies during the day and red sunsets at night. In the case of scattering, that dependence is 1 over the wavelength to the power of 4. On paper, this doesn't look too bad, but let's put some actual numbers to it. Let's consider the best case scenario for Hubble, a red photon with a wavelength of about 630 nanometers. That wavelength of 630 nanometers is going to give us a multiplicative factor of 6 times 10 to the 24. That's 6 with 24 zeros after it. Going to the worst case scenario for Hubble, an ultraviolet photon, and that factor becomes 6 times 10 to the 26 zeros after it. That's 100 times higher, and this is a major problem for Hubble. In practice, this means that a large portion of the light that Hubble should be detecting never makes it to the telescope. Instead, it's scattered along different lines of sight by gas and dust, or it's absorbed and re-emitted at longer wavelengths. We never see that light here on Earth. In fact, around 30% of the total light emitted by the Milky Way and other galaxies like it is in that re-emission from dust, light being absorbed by dust and re-emitted as typically infrared radiation. So clearly viewing the universe at these higher frequencies doesn't quite work. If we could view the universe at longer wavelengths, then perhaps that would solve our problem. Infrared light and other light of longer wavelengths, typically where that wavelength is longer than the size of the dust grain itself, are scattered and absorbed far, far less than a visible photon or something like an ultraviolet or an X-ray photon. Let's think about an infrared photon with a wavelength of around 10 micrometers. That's going to get your multiplicative factor to be 10,000 times smaller than it was for even the red photon. That we can work with. But Hubble can't see this infrared photon. That's where JWST comes in. JWST is an infrared telescope with 2 main missions. The first mission is to look outside our galaxy, to the furthest away, most distant and faintest galaxies. The ones that have had their light redshifted by the expansion of the universe so that we can't see it anymore. Observing these early galaxies will tell us a lot about the early universe, what a galaxy like the Milky Way may have looked like, and tell us a bit about how the universe has evolved. Its other primary mission is looking into these really dense areas of our galaxy, these areas obscured by gas and dust that Hubble has never been able to view again. This is JWST's power. This is the advantage of being an infrared telescope. But JWST is not the first infrared telescope. There have been others, notably the Spitzer Space Telescope. So why is JWST so amazing? Why do astronomers like me get really excited about the results from it? The reason is that it is the largest space telescope we've ever made. The largest mirror we've ever put in space. This is its real power. A massive light bucket with the detectors sensitive to infrared radiation. All this allows the JWST to produce images far sharper and far more accurate than Spitzer could even dream of. There still remains the biggest question when it comes to JWST. Was it worth it? Do the scientific results we get from this amazing observatory justify all the costs? In short, yeah, it justifies it. Hubble has observed some amazing places in our galaxy. Some that come to mind are the Southern Ring Nebula and the Pillars of Creation. These images are iconic. They are some of the most well-known Hubble images ever produced. And while these images look incredible, they don't even begin to tell us the entire story. Fortunately, JWST has had a look as well. Let's compare, shall we? First up is the Southern Ring Nebula, known to astronomers as NGC 3132. This is a planetary nebula. Confusingly, nothing to do with planets. It's where the gaseous outer layers of a dying star have been thrown off, giving us this wonderful nebula that may someday form new stars. Hubble has viewed the Southern Ring Nebula before, and it looks amazing. We can see a star in the centre of the nebula, and the edges of the gas glowing with light reflecting and diffusing through them. But if we take our wavelength selection a little bit longer to the realms of infrared and JWST, the whole scene comes alive and reveals something truly magnificent. Rather than the murky haze of diffuse light that we see in the Hubble image, we see detailed gaseous structure in that nebula. It even reveals another star that just wasn't there in the Hubble image. This is the power of JWST and observing in the infrared in these dusty, dense environments. But this hidden star won't be the first one discovered by JWST. Let us look now at the Pillars of Creation, one of the most iconic images ever taken by Hubble. This is a star-forming region in the Eagle Nebula in the constellation of Serpens. It looks spectacular in the image from Hubble. It's one of the most iconic ones Hubble has ever taken. You see light diffusing through the edges of the gas, and honestly, this is one of my favourite Hubble images ever taken. But if we go into the JWST image, we see so much more detail. We see bright stars in this image. Stars like these four that just aren't there in the Hubble image. At the same time, this image actually reveals some of the limitations of viewing everything in the infrared. Stars that were really bright in the Hubble image, some of them just don't really show up that well in the JWST image. The reason for this is these are very hot stars, emitting a lot more visible light and a lot more ultraviolet and X-ray light, something that JWST is not that sensitive to. So, what is the takeaway? Dust is still awful. You are not going to change my mind on that. It blocks light from some of the most interesting astronomical objects, star-forming regions, active galactic nuclei, hell, the galactic centre. At the same time, the problem of dust has given us sufficient reason to invest and develop a telescope like JWST. This is a tool that we're going to use over the next decade and even longer than that, to really dig into the secrets of our universe, to make new discoveries, and to inspire a whole new generation of people to get into science, to get into astronomy. I'm really looking forward to seeing what JWST reveals beyond the shroud of dust. Thank you for watching this video all the way to the end. I've just moved to Cardiff ahead of starting my PhD in galaxy simulations. This is the first video from the new office. Hope you like the new set. And I'm really excited for what's going to be coming up over the next couple of months. Please make sure that you've subscribed and you've hit the bell icon so you get notified for when I put up new videos. I'm really happy to have my own office space in the new house so that I can actually have a space dedicated to making videos like this. There's going to be loads of stuff coming up over the next few weeks and months. There'll be some videos coming out, if they haven't already, that will be telling you all about that. So all that's left to say is thank you very much for watching. If you're looking for something else to watch, there is something right here, and I will see you in the next one. See ya.